All right, so starting out our chapter 7 here. And so looking at graphing equation lines and linear models, which will then connect to the scatterplot stuff we were doing back in chapter 6 and being able to model that least squares regression line. And so we're looking at some of this is hopefully a refresher, like the idea of y equals mx plus b. And remember that m is our slope and b is our y-intercept. And so we can use that to describe those. And we'll be able to graph equation of a linear model, again modeling that scatter plot and giving us that predictive line as well. So let's look at a couple things here. So looking at our solution. And so this is just substituting values in. So remember our coordinate pair, that's x comma y. So we can just substitute that in. So 1 equals 3 times 2 minus 5. So as we simplify that, all right, we get 1 equals 6 minus 5, and 1 equals 1. So that checks out. So is it a solution? Yes. All right, go and try number 2 there on your own. Give you about 30 seconds to work on it. And so again, just substituting our values in. So I get 9 equals 3 times 4. Notice every time I'm substituting, especially on the multiply side, I get a little lazy on the y side, but when I have anything that I'm going to be multiplying, adding, subtracting, it's good practice to put parentheses around it. Helps define what you're substituting in. Doesn't hurt to put it on this side as well. They just get dropped on the next step. So then I get 9, 3 times 4 is 12, minus 5. 9 equals 7. So that does not work out. So that would be no. All right, so basic definition of graph here. All right, it's an equation in 2 variables. And it's the collection of the set of points that correspond to all solutions of that equation. So any point that is on the equation is a solution, and therefore also must be on the graph. So we want to find 5 solutions of y equals 2x minus 1. And then we want to plot them in the same coordinate plane. So you can make a t-chart here. We have x and our y. So we'll go with 0, 1, 2, 3, 4. You could go with, let's mix it up and flip it. Go a little bit on each side. So we'll go -2, -1, 0, 1, and 5. And then all we're doing is substituting those in. All right, so just taking each of our x values, substituting those in. Another reason to use parentheses, because I've seen students over the years don't in this case, and then they make it look like 2 minus 1, when it really should be multiplication here. And so just finding our y values, that guarantees us that solution. So 2 times -2 is -4, minus 1, so that gives me -5. And then if I do the same with -1, that gives me -2 there. So -3. And then work your ways down. That should be a +2 there. Don't know, I got a 5 there. And even some of you probably starting to see the pattern from the slope going up by 2, so you don't necessarily always have to substitute those in. So let's go ahead and plot those points. Okay, so then remember we go x first, so -2 and then down 5. And then -1, 3, 0, -1, 1, 1, and 2, 3. And then we should get that line that goes right through those. Just like that. All right, and then tying back into our y equals mx plus b here. All right, so then our m is 2, our b is -1. That is our y-intercept. So there's our 0, -1, which is right there. So you can see how we can plot from there. And then 2 was our slope, so up 2 over 1, up 2 over 1. And so we can plot that way as well eventually, which leads us into truly defining it here for you as it written out. All right, so this is what we call slope intercept form. Y equals mx plus b. Now things to understand, even though m and b are variables because they're letters here, within our actual equation, they are constants. Once we've defined the equation, those two things stay exactly the same. And then we have our x-axis, x-intercept, so it's where it crosses the x-axis. And then the point that crosses the y-axis is then our y-intercept. And always our x-intercept is going to be x-intercept comma 0, and our y-intercept is going to be 0 and then b there. All right, so let's look at number 4, and we're going to sketch the graph here now. And so we're going to do this by our slope intercept. So let's define a few things. So our m is -2, which is -2 over 1 for our rise over run. And then our y-intercept is our b, which is at 3, so 0, 3. And then that's where we will start from. So let's do some steps here though, so you can reference these. So step 1, you want to identify your slope, which is your m, which we've done. 2, we want to identify our y-intercept, which is our b. Make sure you also write it down as helpful as the coordinate 0, b. Step 3, we'll start with plotting the y-intercept. So let's do that. So 0, 3. Step 4 is we're going to plot a second point now. And we do that by using our slope. And so again, our slope was -2. So rise or run, that means we're going to go down 1, 2, and then we're going to run 1. That gives us our next point. And then we can draw those two at that point. I'm going to do a couple more here. So I'm going to rise -2 and then run 1. And then we can also go the other direction if you wanted. Those two things, when it is -2 over 1, could also be +2 over -1, which means I can rise +2 and then run a -1 to give me that point right there. And then we can connect our dots, putting arrows on there because that line extends forever, just not through those points. And that's our step 5. Draw the line, connecting the dots. All right, so you need at least 2 to connect the dots. We don't always have to do more. I was just doing a little extra. Also helps identify where those other ones are to get a more accurate line drawn there. All right, so as we look at 5 here, it says find the y-intercept by looking at the graph. And so just by looking at our graph, remember our y-intercept is where we cross the y-axis, so that would be that point there. So 0, 3. And then here's how we can find it if we haven't graphed it yet. And you can find a y-intercept always by this, regardless of the equation. I know our equation is in y-intercept mode. But if we substitute 0 in for x, we can then solve and you get y equals 3, which then gives us that same. So just some different ways to identify important features of a graph. All right, so I'm going to have you sketch this graph at 7 here. Try your hand at that. Identify your y-intercept as well there in 8. All right, with you having tried that now, let's look at number 9. Now 9, some students freak out and like it looks so different. We're still y equals, just like we are on all the previous ones, but there is no x in there. But if we put this into our y equals mx plus b form, the b is still our 3, and there is no x, which then means m has to be what? What times x would make the x disappear? Well, if m was 0, 0 times x would then be 0, so then that would go away, and we're left with just y equals 3. So our m is 0, our b is 3, so our y-intercept is 0, 3. And then how do we plot an x point? Well, our m is 0, so our slope, our rise over run, is 0. So I rise 0 and I run. Well, that's our part. We run whatever, because 0 over 1 is 0, 0 over -1 is 0, 0 over 1,233 is 0, 0 over 6, 7 is 0. So I can run whatever I want. So really, we just plot some horizontal points, and this is a horizontal line that goes through y equals 3 all the way across. And as we already talked about, our y-intercept is 0, comma. All right, let's look at our next example here. All right, 11, now we're sketching the graph of x equals 2. Now this one definitely looks different. There isn't the y equals there. And so how do we do this? All right, well, where does x equal 2? X equals 2 right along this line fully. And does it say where it stops? It doesn't. So we need something that x always equals 2. So then this graph is now just a vertical line that's going through where x equals 2 at. So if you notice, comparing these two, y equals, y is a vertical number, so we plot it on the vertical line, but it runs horizontally because we need y to always be equal to 3. So it gets plotted here, but it runs horizontally because y always needs to equal 3. And then x equals 2. Here's where x equals 2 on a horizontal, but it's a vertical line because x always has to equal 2. And then the question here is, well, what is the y-intercept? Well, remember the definition of y-intercept is when we cross our y-axis, which is right here, which we don't, and so there is no y-intercept for this equation. And so again, they kind of define it as x equals a for that. It's just another constant that now gives us that vertical line. All All right, let's look at an example and start tying this back into some previous information. Okay, so now when we're not describing as we call an authentic situation, we use X and Y. X is our explanatory, Y is our response. When we talked about explanatory and response previously, we use letters that corresponded to that. It helps us remember. Letters are just placeholders. They're variables. In this case, they're specific constants that are placeholders for the values that we have that are within that context. So as we do through this context, we're going to now identify our explanatory and response with those specific letters. All right, so in the UK, nervous dental patients are sometimes given a sedative to calm them. To administer the sedative, the dentist performs a cannulation, which involves inserting a thin tube into a veins patient. An experiment involving 20 individuals, researchers tested whether the amount of the pain of individuals experienced in cannulation explains the level of anxiety that the individuals predicted they would experience by undergoing cannulation again. After undergoing cannulations, the individuals rated their experience of pain from 0 to 100 and their predicted anxieties about undergoing cannulations again from 0 to 100. The ratings are below. So we have a 2-column, but it's broken up over the course of 1, 2, 3, 4 groupings, but it's still column 1 and then column 2 here. All right, so they tell us let A be the anxiety rating, and then P is the pain after undergoing it. So what is our explanatory and what is our response? Okay, so our explanatory is kind of what's happening first. So they rate their pain. So explanatory is going to be our P. And then we're trying to predict their anxieties. And that's coming next. So they do the pain initially, and then they're trying to predict with their anxiety. And we get a nice little clue about that as well. The prediction becomes your response. That's what we're trying to predict off of our data. And then so off of this, we are then going to construct a scatter plot using this table right here. So I'll give you a minute to set that up, try your own hand, and then I'll talk through it. All right, and that's your scatter plot going by tens and tens on each one because of the values that we had across, kind of fits them all in. And so let's answer a couple things here. So describe and interpret the direction. Okay, so our direction, right, is our values are going to the right. What's happening? They're going up. So it is positive. And I would say it is even strong, maybe moderate strong at the weakest. And then they give us a graph for this. And so we can go ahead and graph this point. And so our y-intercept is 171. So it's going to be, all right, this is 0, 0 right here. And so that point then is about right there. And then I'm going to rise 1 and go up. A graph that looks a little bit like that. So does this model come close? I would say, yeah, it becomes pretty close to modeling. We got about an even distribution between ones on the top, ones on the bottom, kind of splitting it there. We're a little off here, but that has to be balanced. Maybe a little bit there. Potential outlier. It's pulling a little off in that direction as well. Okay, so then 18, where these become important and helpful is now we want to predict what's going to happen next. Okay, so given someone's pain, can we predict their anxiety? And then what do we need? What decisions do we need to make after that? So use a model, predict the anxiety rating of a patient would, after undergoing cannulation, after having undergone one with a pain rating of 70. So the next time, where would they be? And so we're going to substitute that in. We can also go off of, hey, what does this look like if we go up 70? Where's that at? Right, it's maybe around 71, 72. We have our model, we can substitute that in. So A equals 0.91 times 70 plus 1.71. Okay, so then looking at it, if I substitute that all in, I get 64.41. And so that being a little off from our graph, so we would maybe need to adjust that line down a little bit there. All right, let's go back up to this one so you can check your work. All right, so our y-intercept is -2. Our slope is 3/2, so I'm going to rise 1, 2, 3 and run 1, 2. And I'll show you on this one. All right, you can just make your graph of those two lines and be pretty good. And then our y-intercept is that, so at 0, -2. So you can check your work there. All right, and then so to wrap it up here, as we're talking about finishing up the school for the semester, and the elves are also getting out of their schools so they can do all their hard work for Santa. Do you know what the first thing elves learn in school? Yeah, a lot of people would think it's how to wrap presents or build toys, but I mean, it should be obvious, so it's not much different than us. They need to learn their alphabet.